Okay, today we're getting ready for the test, which is going to be tomorrow. The test is on chapter 1, and there was a whole bunch of topics, all the way from stuff as easy as take this number line. This is a more complicated one, actually. And tell me how you could write that in interval notation. And yeah, this point's included, but there's a gap in here. How are you going to handle that? I'm going to pause for a second while you try to write that in interval notation. All right, so here's how you should have done this one. Would you agree that 5 to 9 is something we've done several times? Raise your hand if you're good at that part. Okay, good. Now, how to do just an individual number? Who has an idea? I didn't show you these, but you should be able to kind of figure it out. There's 2 options. What do you think? You got it. That's pretty much it. How many of you did that? Raise your hand if you did. Okay, how many of you put from 3 to 3? Also another option. That's also good. Any other ways you did that you want to share? Okay, because I think that'd be the only 2 ways I would take. But this is better, because there's no reason to have to put 3 comma 3. All right, the next part is it where those overlap, intersect, or is it where all of them just join together? To join together. So what should I put between them? Union. If you put an intersect, it is wrong, because the intersection of those 2 is the empty set. There is no intersection. They don't overlap. So if you put this intersected with that, you're saying that the number line should show nothing, because this intersected with that, the answer to it is nothing. So union is the only thing you could have had there. Raise your hand if you were totally right on that. All right, and if you weren't, as long as you get it now, we're good. Any more questions about how that would work? All right, you should have a blank notability doc. You should be doing these problems with me. All right, so the next one is write the same one in set builder notation. I'll pause for a minute and walk around and check if you're doing it right. Let's see if you did this one right. Start with, you need the little squiggly thing, and then we have x, where x is equal to 3 is unioned with 5 is less than or equal to x is less than 9, and squiggle. Is there another way? Yes. If you wanted to, you could write that this has to be an overlap of 5 is greater than or equal to x. Actually, I should say it this way. X is greater than or equal to 5 intersected with x is less than 9. I'm curious, how many chose option blue? How many chose option green? All right, either one's fine. All right. Yeah, I think that pretty much says it. So that's what kind of notation? Step builder. Good. Then yesterday I taught you how to figure out if things have certain kinds of symmetry. Let's just look at the pictures for a minute. What kind of symmetry does that guy have? Origin symmetry. Good. What kind of symmetry does that one have? Y-axis. Good. And then the last one's x-axis symmetry. It'll be something like that. Okay. All right, but then there's the algebraic way. So if I show you this thing that you don't even know what it looks like, y equals 6x squared minus 2. You might kind of know what it looks like, but without looking at the picture, how could you prove for me that this does not have x-axis symmetry? Well, here's the setup. X comma y is normal. To do the other one, x-axis symmetry, can you please put the correct one right there and turn it my way? And I will tell you if you're doing it right. I want to see the test for x-axis symmetry. Everybody has showed me so far has got it. X-axis symmetry leaves the x alone. The other one's got the negative. Good. Raise your hand if you had that one right. All right, now actually show me the proof. You got to know what to put here, and you got to know what to put here. And if you just write the answer, you don't get any credit. You got to show your work, and there's something specific in the work that's got to be there. Otherwise, I'm going to say you didn't prove anything. Pause while you give that one a try. Okay, let's see how you did here. This one should be the original because you stick in x for x and y for y. So it's y equals 6x squared minus 2. How many of you started right? Good. Now, Mr. A, well, your first name starts with A. I don't want to say it on the video. Tell me how to do this other side. Ah, parentheses. Keep going. Excellent. And now what do I drop in the parentheses? And the negative y goes here, and the x goes here. All right. Why are those parentheses so important? In this particular problem, the negative doesn't happen to be being squared, so it isn't as big of a deal. But if this had a negative right there, 6 minus x squared is totally different than 6 parentheses means times negative x squared. So anyway, it doesn't matter as much here. But now I get this, and a lot of kids are going to do this. And they're going to say, I proved it's not true. What's wrong? Yes. Solve it for y. Y equals negative 6x squared plus 2. Now it's a fair comparison because they both start with y equals. X squared minus 2, negative x squared plus 2. They are different. Therefore, this is not got that kind of symmetry. Does not have XX symmetry. Okay. How many of you think you're going to get that right? Then tell me, what are the x and y intercepts of that equation? Don't try to do it from a picture. You need to know the rule. The x-intercept is where, say it. Excellent. And the y-intercept is where x equals 0. Good. I'll pause while you try that one. Okay, so the hard kind is where we do y equals 0. That's the x-intercepts. 0 equals 6x squared minus 2. Now there's a couple ways you can do this. I have tried to pound it into your head. If you can factor it, you should. So factoring is the best way. I'll show you. 2 comes out. 3x squared minus 3. Wait a minute, something wrong there. Minus 1, thank you. Okay. Then, this is the only part I need to solve for equal to 0. So that equals 0. 3x squared minus 1 equals 0. So 3x squared equals 1. So x squared equals 1/3. Sorry, you guys are the first one where I made this complicated here. Normally, once it factored, it came down to this, something like 2x minus 1 and x plus 3. That's where they normally come out when you factor them. But this one has an x squared in it. So this kind's easy. You just say, oh, negative 3 is one of the solutions. And over here, x equals 1/2 is the other solution. That's how a lot of times it'll be. But for the one I gave you, it's square root of this. And then let's see who remembered that this is the absolute value of x equals the square root of 1/3. And therefore, it's 2 things. Ooh, pretty intense. Who got plus and minus the square root of 1/3? Nice. Way more than I thought would do that. Just curious, how many of you actually showed an absolute value in your work? That's the harder part to get people to understand, but some of you did at least. Okay, so now that was the x-intercepts where y is 0. The y-intercept is super simple. The y-intercept is where x is 0. Put a 0 here, and then this whole thing becomes 0, and so y equals negative 2. Raise your hand if you had that one right. That's a piece of cake. Okay, good. All right, so that's a kind of not everything review. That's a pretty thorough review. Now I'm about to give you a little quiz that is for practice today. It's not the real test. The real test is tomorrow. And I'd like you to clear off your desks, have something to write with. I'm going to pause while I hand this out. Okay, everybody flip your quiz over. On the back side, I want to add one question to it because I think this is an important kind we haven't talked about yet. I want you to see if you remember how to graph things in set builder notation. So it's graph x where comma y where 2 is less than x is less than or equal to 5. And let's put in a comma, which, by the way, do you remember what comma means? Intersect with y is greater than 2. Graph that one. That's on the back side of your quiz. Okay? That's an extra question I'm adding because I think it's worth it. So I'm going to pause for a second while you guys work on that quiz, and then we'll come back and grade it. Do your best. I'm back, and we're going to talk through that quiz and the graph on the back side of it. I'm going to start with the graph that is on the board here, the back side of the quiz. Hopefully you've got that, and it shouldn't have been. Yeah, okay. This is not an easy one. I get that it's not an easy one. All right, this is where x is 2, so I'm going to make it dotted because it can't be 2. Did you have a dotted line right there? Good. Next one is a solid line at 5. And it's what's in between there. Now, if that was it, I'd be done. But it has this extra little stuff here. Intersected with y is bigger than 2. Well, here's where y is 2, but I'm making it dotted because it's y is not 2, it's bigger than 2. So instead of shading above it the whole way, which I could do here, but I'm not going to do, why am I not going to do that? Because I don't want to mess up my graph too much. Because I know I'm going to have to erase everything that's not in my final answer. My final answer is where they intersect or overlap, and that's in here. Now, I have left purposely, the left side, I can still see there's a dotted line in there, and on the bottom, I can still see there's a dotted line in there. Now, if I did that, I would lose part credit because I haven't cleared it up and made it obvious that only that is my final answer. Now, I could have full credit for it, except I would need numbers here and here. So this is 2 and this is 5. And this was at positive 2. There we go. Okay, raise your hand if you had that one right. Awesome. Questions? Yes? Yes, they have to be dotted lines or solid lines. And if I can't tell the difference, you're not going to get full credit. Okay, so that has to be a dotted line, that has to be a dotted line, that has to be solid, and that has to be solid. Are you asking, like, can you have these lines? Okay, yes, dotted lines you can have. If any of them had been a solid line, for instance, that line, you really are not supposed to have that line. Do you get that that implies your answer keeps going down this way? So you shouldn't have any solid lines outside of your shaded area. Now that'd be, I don't know if I'd be that tough to say I'm going to mark it all wrong because of one little trailing line there, but I could. Dotted lines, though, are indications it's not on that line. So these dotted lines extended out here and here and here are no big deal. Okay. Any other questions about that one? Okay, how many of you got that one right? Okay, good. Now, today is not a normal quiz in that you're going to grade it yourself. You're not even going to exchange it with anybody. You're just going to grade it yourself. And this is just for your own knowledge of how well you're doing. So would you please flip it over? And now we will grade the front side. Since the questions can't be seen here, I may talk through a few more on the video in a moment, but I'm going to pause while we're grading the quiz we took in class. So here's a question about y-axis symmetry. Does this have y-axis symmetry? I know it's a little different than the one that was up there, but does this have y-axis symmetry, even though it goes forever in both directions? It does not. Y-axis symmetry would mean there'd have to be something across the y-axis, which is that one, that matches up with it. Straight over there, there'd have to be something. So you pick a point, any point, like dot right there. That does not have y-axis symmetry because there's no dot over here that goes with it. But it does have origin symmetry. Why? Because if you take a line and draw it from my point that I picked and go right through the origin, then there's another point down there that corresponds with it. I didn't draw this perfectly, but that in general is the picture of a function that has origin symmetry. Okay, let's move on to other parts of the quiz. I'll pause again. So that line, oh wait, I want to pause again. So if I'm asked to find the y-intercept on this one, nope, sorry, the x-intercept on this one, I set y equal to 0. The y was right there. Now it's 0. And now my little saying, if you can factor it, you should, comes in. X comes out, and then I have x squared minus 9. And then if you can factor it, you should. So do you notice that this becomes x plus 3 and x minus 3? Raise your hand if you factored it all the way. Awesome. See, factoring is so powerful. Yeah, you can solve this little thing a different way, but it involves square rooting variables, which involves absolute values and is really complicated. This just gives you the answers nice and easy. X is 3, x is negative 3, and x is 0. There are 3 of them, which makes sense because whenever there's a 3 for a power, you're going to find there's 3 answers. Okay? If there's a 2 for a power, then you're going to have 2 answers. All right. So those are the 3. That problem was worth 2 points on our little quiz in class. I'll pause for a second while we continue. I think we've gone through enough things to feel like you are pretty well ready for the test tomorrow. Again, I'm planning on having no new homework, just that top 20 version 2 that I assigned before. Get that done because we'll have that ready for Monday. And same with the lab, have that ready for Monday. We'll get both of those things knocked out on Monday. Tomorrow is the test. That's all I got for you for today.